welcome to the Agricultural Engineering Podcast. This podcast covers all aspects of agricultural engineering. It is produced by the South African Institute of Agricultural Engineers. The series of episodes that will be brought to you has been funded by the Royal Academy of Engineering. We encourage you to tune in and explore the exciting world of agricultural engineering with us. My name is Maharaj, and I'm your host for today's episode. So today we've got a special guest all the way from the United States of America, and I'll let Prof. Srivasta introduce himself.
My name is Ajit Srivasta. I'm a professor in Biosystems and Agricultural Engineering at Michigan State University, and I'm really happy to be here.
It's really good to meet you in person. I'm pretty sure that most of the agricultural engineers from South Africa have seen your name on textbooks for the bioproduction systems and power and traction modules that we do at university. And it's really good to meet you in person. And I think a good way to start this podcast is to ask you if mechanization and power and traction is your key focus area of your research and work.
Yes, it is. I have worked in the area of agricultural mechanization throughout my entire professional career. I think it's an important aspect of the profession, being able to provide tools and technologies to farmers to be more productive and profitable and manage their farm in a sustainable manner is what the mechanization is. And I've enjoyed working in it. I've conducted research and written textbooks and I've stayed with it for a long time.
I see what you mean, Prof. And I like that you speak about sustainability and mechanization together. I think a lot of people generally think about machines and they just imagine these big diesel tractors plowing through the land. But when it comes to sustainable mechanization, how would you describe that? And what is the best way to adopt sustainable mechanization in agriculture?
Yes, a very good question. Let me first address your earlier comment about diesel and large. Mechanization has kind of grown to meet the needs of the farmers, and especially in the U.S., the farms are large, and they are getting larger because there are less people farming, so the farms are getting larger, and the farmers need a way to manage those farms. Sometimes the single-family farm manages 3,000 acres. So the equipment had to be large because crops, all farming operations are very timely. You don't have forever to plant or harvest. So the tractors became big and combines became big to give farmers capability for harvesting. The sustainability aspect of mechanization is an important one because there are two things that should be taken into account when we're talking about sustainable mechanization. Number one is the direct impact of mechanization on the environment. Emission comes to mind, which is very obvious. A big tractor, big diesel, and people look at that. The second is bigger, heavier machines create compaction in soil, and that is not a positive thing because it impacts how roots grow and how water moves through the ground. The other aspect of mechanization is looking at the farming systems, and one of the speakers spoke about that, the principles of sustainable farming today, and actually I made a note of that, which was a very interesting idea, is let's take a look at what kinds of farming practices leads to sustainability of soil quality, and the environment, and so I would say the sustainable mechanization depends upon agroecology, the farming systems, and as the word sustainable means, we want to be able to farm for thousands of years, not just 1 or 2 years. And so how can the operations that we use to produce crop using mechanization continue to improve soils and the environment? And so that takes on a different challenge, and it's not always bigger is better, but what is more sustainable and affordable So this is something which will, as we learn more about farming system, the definition of sustainable mechanization will continue to evolve in that context.
I really enjoyed listening to your answers to that question. And I'm sure if your background is not in mechanization like me, you generally assume the worst case scenario, but you've summed it up quite nicely. And as we look into your answer and break it down, I think what you basically are saying is that if you look at the balance and if you get your practices and principles correct, then when you look at mechanization and you have the entire system working together, you can have sustainability and mechanization used in the same sentence. And you can then tick your boxes of sustainability, producing food, producing more food for the growing population while still considering the future. And I think just on that, we've heard the term producing more with less quite often. And I'm just interested in how mechanization would fit into that, because obviously, with the growing population, farms are becoming, unfortunately, a bit less productive because of the poor practices generally associated with traditional farming. So, what technology do you think can be adopted that can help farmers produce more with what they have?
Yeah, very good question. And that was the main point of my presentation yesterday in the conference. As we all know that, as you mentioned, the need for producing food because of global trends such as population growth and diet transformation associated with growing middle class and urbanization, we nearly have to double our food production by the year 2050. We have limited land resources. The land is not getting any better. We have limited water resources and energy. So we have to look for ways to produce that food that we need from the same piece of land in a more intensive way. And one of the term that Sir Gordon Conway coined called sustainable intensification. And that means you grow multiple crops or even dual crops in the same land. And that would require things to be done in a timely manner. If you're practicing conservation agriculture, that would require a different set of tools that will require a little bit more power than a manual labor can provide, or even and draft animals can provide. So we have to look at mechanization through mechanical means of power, and so all of that has to be looked at, and we have to also think about, the conventional tillage is not necessarily the best way to go. So when we modify our farming systems, the mechanization has to evolve with it. So it's a dynamic process, and it has to change with the needs of the farming systems and the need to grow more food. So I think mechanization will always be needed, and it is proven by looking at a macro level in different parts of the world, practically. Mechanization has played a major role in improving productivity of farmers, and when we talk about productivity, we should also keep in mind that farmers have to be profitable, and mechanization can play a major role in not only food security but to make them more profitable.
Yeah, Prof, I really like that you've mentioned profitability and food security. And, generally when we think about profit, you're not really associating profit and sustainability with agriculture, because you generally think you need to put more into the land to get more out. But with that, I think there has been some changes in the way people are farming and the way people think. So I just wanted to ask you about what's your experience with change and behavior with humans, and what do you think could encourage people to change? Because, for example, if you've got a farm and you can see that you're losing topsoil, but with conventional knowledge, farmers would still go in and plow the soil, and I'd say that would aggravate the problem. So, from a change or social point of view, what is some advice that you could give people or farmers in the industry to encourage them to think a bit more holistically and look at the earth as a living organism, and also look into lead change, but using the tools that they know how to use, or maybe using tools in a different way, or just maybe getting them to think differently about how they approach farming?
Yeah, I think it boils down to mindset and creating a scenario where we communicate, and the farmers know it. I mean, they're responding to the needs. When the food security is the number one issue, and then you will produce food, whatever it takes to produce food to feed your family and to society. But I think when we go beyond food security, we then begin to think about sustainability and the environment and the quality of life, more or less. So I think we are moving in that direction. We have to continue to talk about it because, people don't change their practices overnight, and it takes some demonstrations, some conversations to convince them that we're going to have to grow food from now on forever, because as long as we inhabit Earth, we have to be able to grow, and we cannot let soils degrade. So our farming practices have to be such that does not cause any deterioration of soil and quality, and I think people are taking a look at that, and they're taking it seriously. But at the same time, we have to provide them with basically methods and tools to maintain, to achieve sustainability. And that's where we come in as agricultural engineers or biosystems engineers, is to say this is a better way of doing it, a better way of producing it, and the profitability comes in because we have to make a living. Even farmers have to make a living, and that this is a better way of doing it, more sustainable way of doing it, and they will respond to it. And I think there are a lot of farmers I know want to be sustainable. They are the steward of land, and they want to make sure that they leave it better than they found it. But we have to provide them with methods and tools to do it.
That answer really shows how diverse agricultural engineers are. From speaking about mechanization, not forgetting the environment, and then bringing in the social aspect and behavioral change. And I think generally in South Africa and the rest of the world, there are different types of farmers. So you've got your smallholder farmers, you've got your farmers, gardeners that plant for their family in their backyard, and then obviously you've got your commercial farmers. But it's just great listening to you, because when you speak, you tick the boxes for all these different types of people that are growing crops in Africa and the rest of the world. So yeah, just on that, I think it'll be really good to get your advice on some things, because there are a lot of young agricultural engineers that listen to the podcast. So is there anything that you would like to tell a young engineer listening to the podcast about your journey, how you got into agricultural engineering, and what made you pursue your postgraduate studies in agri-engineering and sticking in the field for so many years?
Surely. I grew up on a farm. Okay. It was a 16,000 acre farm owned by the state, in which I grew up in India. And my father was an employee, so it was not my family farm, but I grew up in the middle of farm. And during summers, there was nothing to do. There was no movie halls or coffee shop to go to. So to keep myself busy, I would just ride my bike over to the field, and if somebody operating a tractor, I would want to say, can I operate the tractor? And they were very happy to let me do it, because it was very hot and they wanted to find a shade tree so they can rest. And I was just happy to be on the tractor doing something. So when I was working in driving tractor, pulling a plow, there was something satisfying about it, even though it was 120 degrees Fahrenheit with no canopy, and the sun is beating down and the hot air from the engine is blowing on you. Yeah. It was not very pleasant, but that didn't matter. It was something that I felt when I would look back and see the plow turn the soil over, and then next thing is that you are planting, and the plant is growing and the crop is being harvested. There's something satisfying about it, that you are doing something. And then I was lucky enough that India decided to open the first land grant, U.S. land grant system based university in the middle of the farm. And the year I was finishing high school, that was the year they opened, they started admitting the first class in the agricultural engineering. And it made sense to me that since I enjoyed working with machines, and here is a world-class university in the backyard, and they're admitting, and so I applied, I was admitted, and I graduated with a degree in ag engineering, and I was lucky enough to be hired by the same farm as an assistant agricultural engineer, and I worked for them for about a year and a half, and that's where I got involved in machine design. We, for example, my first task was to harvest 6,000 acres of high-yielding variety of Sonora 64 wheat, and I was in charge, and we had a fleet of 10 combines, and which I repaired, and we harvested wheat, and I learned a lot. I designed fertilizer spreaders that were built in India because imported fertilizer spreaders were very expensive. So I started looking at what I had learned in class, in the lab. I was able to put to use in a large scale. And then I thought I was enjoying what I was doing, but then I said, what is the next step? And I thought maybe I should go, but since I enjoy developing new machines and doing research, I should go into grad school, but I want to do it in the U.S. And main reason for that was that I had befriended some Peace Corps volunteers in the U.S. And one of the Peace Corps volunteers, Joe Pena, was from University of Wisconsin, and he was an ag engineer. And so that's how I kind of got to know him, and that prompted me to go into ag engineering. And then I said I really want to go to U.S. and get a graduate degree. So I started applying. I was admitted at Rutgers University, and as a part of my master's thesis, I worked on asparagus harvesters. And because New Jersey is a big asparagus growing state, I worked on asparagus harvester. Once I graduated, my family wanted me to come back and get the same job back that I had, and I said, master's degree only gives you a taste for research. I said, I have to go on for PhD. Yeah. And I kept applying, and Ohio State University offered me admission and assistantship. So I went there. There I worked on grain combines, and my research led to the development of rotary combines, and I was pretty proud of that. After I finished, I did 2 years of postdoctoral work, worked on application of ultrasound in agriculture. That was very, very, very intriguing research. And then I went to Cornell University for 3 years, working on developing testing procedure for safety cabs on tractors. And after that project ended, I was looking for more permanent position, and then Michigan State University had a position opening in the machinery area for teaching and research, and I applied. Luckily, I was selected. That was 47 years ago. And I've been teaching, conducting research on various aspects of mechanization. I've written a textbook on that. And then I was appointed as department chair in 1997. which I served as the chair for 18 years. And during the time, we were transitioning from ag engineering to something else, and was instrumental in changing our degree program from ag engineering to biosystems engineering, which had a tremendous impact on enrollment and employability. And then in 2015, I decided to step down, and I thought, okay, what's my next gig, so to speak? And I thought, what I'm doing is needed much more in developing countries. So then I received a grant from USAID in developing appropriate scale mechanization for smallholders, and that brought me to Africa. So I've been working in Africa for 10 plus years on different projects, and I find it very, very satisfying because so during that project, working with, as you know, that there are 500 million farmers in the world. 80% of them are smallholders. And so as we look at doubling our food production, those smallholder farmers will play a major role. So how do we increase the productivity of smallholder farmers? And I believe mechanization is an answer, not the answer, but is an answer to increase productivity. And so once I was working on that, I had another revelation, and that is, why not deploy modern tools to increase productivity? Modern doesn't necessarily mean big, but appropriate scale. So I then was involved in a new initiative under American Society of Agricultural Engineers called Modernizing African Agri-Food System. And so we have been promoting that. We're trying to work with different groups, so trying to develop modern technologies at a scale which is appropriate for smallholders to make them productive and profitable.
Wow, Prof, your journey is really interesting. And just listening to you going from tractors without a canopy to now, if you think about it, there's tractors with air conditioning in them. So it's really good to reflect on history and how much agriculture and the machines used in agriculture have developed over time. And you've even mentioned ultrasound and some of the innovative work you've done in the industry. But the smallholder work that you now focused on is quite interesting, because when you speak about modern technology for smallholder farmers, obviously some smallholder farmers may not have access to a lot of money or energy. But maybe just one more question, or maybe you could give us a type of example of a tool or modern tool that smallholder farmers could use, and a tool that has potential moving into the future that can help address some of the challenges that you've spoke about. So what smallholder farmers could use to improve productivity, be sustainable, and basically help the farmers to grow more food?
Yeah, very good question. Certainly, even the simple tools are too expensive for smallholders to own. So the question is, what is a business model that will make those tools available as service to farmers? So the more I read, the more I think about it, I'm convinced that ag service provider model is the best way to go. And these service providers are deploying modern tools, because modern tools require a level of competency and training and maintenance, which farmers just don't have the time and the resources to do. But if there is a small business which is serving many farmers, and I will give an example. For example, if a company owns a couple of drones, and they say, we will go and scout, we can do spraying for a fee. You don't have to own or know how to operate drone. We will come and do that. And so that is a good example how we can make modern tools available to farmers and make it affordable.
Prof, I think that's a really good tool or gadget that you mentioned, because if you think about something like drones, the technology gives you a level of precision that you'd not have in the past. You can map out your entire flight plan for massive areas, and using drones can save you time and money. And it's not only the commercial farmers that can use drones. So, for example, you could have one pilot service a large area with multiple different people, so you can address the challenges that they have using modern technology, and they don't even need to own the drone. So yes, I have to reiterate that is a really good point, and I'm sure that we can speak for a very long time on this topic alone, but just in the interest of time, I wanted to ask you if there's a website or any way of work, any way for people to see the work that you've done. So I know a lot of professors have personal websites that people interested can go onto and have a look at the type of research that is being done and the work that you are involved in. So if you could please give us some links to your work or websites, that would be really appreciated.
I would say the best way is that go to our department website and then you can find me there. For some reason, I've not put a lot of my stuff on the website. A lot of faculty use their website as a way to tell the world. I have not done that, so my website doesn't have a lot of things. But I think the best way would be if you go to the department website and you look at not just what I'm doing, but my colleagues are doing. I think that will give you a sense of what we at MSU are doing in ag engineering.
Okay, I'm definitely going to check out the university website. And I'm sure that if we look on Google Scholar or research websites and portals, we will definitely find some of the work that you've done in the past and that you are pursuing at the moment. But I have to say, it's been an interesting conversation, and I'm definitely looking forward to seeing the work that you do in the future, especially with smallholder farmers in Africa. Okay, thank you, Prof, once again, and goodbye.
Thank you. Enjoyed talking with you.
Okay, so that's a wrap with Prof. Ajit Srivasta from the University of Michigan. And it's been great chatting to him about agriculture, mechanization, sustainability, profitability, smallholder farmers. And once again, the SAI podcast will be back with another episode. So please don't forget to like, subscribe, and follow the podcast, and keep your eye out for the next episode.